Hello everyone. Now let's proceed with the next subtopic, the measurement of noise pollution. By the end of this topic, students should be able to achieve three main learning outcomes. First, you should be able to identify the objective of noise measurement, understanding why we need to measure noise in the first place, whether for regulatory, health, or planning purpose. Second, you will be able to list the key parameters that are typically measured in noise measurement, such as sound pressure level, LEQ, Lmax, and frequency. And third, you will be able to describe the instrument used in noise measurement, like sound level meters and noise dosimeters, and also understand how to use them correctly in different settings. Noise pollution cannot be effectively managed without accurate measurement. By measuring noise levels, we gain important insights into exposure patterns. We can identify hazardous zones and ensure compliance with legal standards. This process is crucial in protecting public health, especially in both environmental and occupational health settings, where people may be exposed to harmful noise levels on a daily basis. Therefore, understanding how to measure noise accurately is the first step in controlling its impact. Let's begin with the definition of noise measurement. Noise measurement is the process of quantifying sound levels in the environment using the right instrument and standardized method. This process is essential for a few key reasons. First, it allows us to assess noise exposure, how much noise people are subjected to in a specific setting. Second, it helps in evaluating whether the noise levels comply with regulations or exceed safe limits. And third, it provides the foundation for implementing noise control strategies to reduce harmful exposure and protect public health. In short, accurate noise measurement is a crucial step in environmental and occupational health practice. Noise measurement serves several important objectives in environmental and occupational health. First, it helps us to assess noise exposure both in the environment and in the workplace. This is crucial for identifying harmful noise levels that could affect human health. Second, we use noise measurement to compare the levels recorded with established regulatory limits, such as those set by the World Health Organization or Department of Occupational Safety and Health Malaysia. This ensures compliance and protects communities and workers. Third, measurements help us identify the source and peak times of noise pollution, which is very useful for targeted interventions. And finally, the data collected supports risk assessment and noise mitigation planning, helping policymakers and environmental health officers make informed decisions to reduce exposure and improve public well-being. Noise measurement plays an important role in the field of environmental health. First, it is used to assess community noise levels arising from sources such as traffic, construction sites, and industrial activities. These assessments help determine whether the noise level poses a risk to public health. Secondly, noise monitoring helps in investigating complaints about nuisance noise. For example, disturbance from loud neighbor, event, or factories operating near residential areas. Lastly, the data gathered from noise assessment supports urban planning, zoning decision, and the development of public health policies. It ensures that residential and sensitive areas are protected from excessive noise exposure. By applying this practice, environmental health officers can help create healthier and more livable communities. When measuring noise, several key parameters are used to describe and evaluate sound level accurately. First, we have the sound pressure level or SPL, which is measured in decibel. It reflects the intensity of the sound pressure perceived by our ears. Next is the LEQ, equivalent continuous sound level, which represents the average noise level over a specific time period. This is particularly useful for assessing fluctuating noise environment. Then we have Lmax, maximum sound level, which indicates the highest recorded sound level during the measurement period. Peak sound level measures the instantaneous highest pressure level. This is important in environment with sudden loud noise such as explosion or machinery impact. Finally, we measure frequency expressed in hertz. This determines the pitch of the sound, whether it is high or low. Together, these parameters provide a comprehensive picture of the noise environment and its potential impact. In noise measurement, we commonly use three main types of instruments. First, the sound level meter or SLM is used to measure sound pressure levels in real time. It often includes A weighting to reflect how the human ear perceives sound. SLM comes in class 1, which offers high accuracy, and class 2, which is suitable for general environmental use. Second, we have the noise dosimeter. This device is typically worn by workers to track their personal noise exposure throughout a shift. It is especially useful in occupational noise assessment, helping employers ensure compliance with exposure limits. Third, the octave band analyzer breaks sound into different frequency bands. This tool is important when we need to identify specific sources of noise and determine suitable control measures. Each instrument plays a crucial role depending on the type of noise environment being assessed. Let's look at the steps involved in measuring noise pollution. Step 1. First, we need to select appropriate equipment and setting. This includes choosing the right sound level meter and adjusting the settings such as A weighting for human hearing sensitivity and the response time, whether slow or fast. Next, we calibrate the instrument both before and after the measurement to ensure accurate and reliable readings. Then we identify suitable measurement points and the duration of monitoring. For example, we may measure near a roadside, a construction site, or close to noisy machinery. Step 4. At each measurement point, we record both the background noise level as well as the peak noise level to capture the variation in sound intensity. Finally, we interpret the collected data and compare it with relevant guidelines or standards, such as those provided by the Department of Environment, the Department of Occupational Safety and Health, or the World Health Organization, to determine if the noise levels are within safe limits. These 5 steps are essential to accurately assess environmental noise and its potential impact on human health and well-being. When measuring and assessing noise pollution, it's important to refer to established standards and guidelines to ensure accuracy and compliance. The first is the WHO Guidelines for Community Noise, which provide recommended noise limits to protect public health, especially in residential and sensitive areas like schools and hospitals. Next, we have the Factories and Machinery Noise Exposure Regulation 1989 under Malaysian law. This regulation sets permissible exposure limits for occupational noise and outlines the responsibilities for employers in protecting workers from excessive noise. Lastly, the MSISO 1996. It is the standards provide guidelines on the description and measurement of environmental noise. This includes definition, measurement method, and evaluation technique that help standardize noise assessment across different environments. These references serve as the foundation for setting acceptable noise threshold and designing effective noise control strategies. In conclusion, accurate noise measurement is a critical step in managing and addressing noise pollution. It lays the foundation for legal enforcement, support health risk assessment, and guides the development of effective noise control strategies. For environmental health practitioners, having the knowledge and practical skills to conduct proper noise assessment is essential. Whether in community setting, industrial area, or workplace, the ability to measure and interpret noise data is key to protecting public health and ensuring a safe and sustainable environment. That brings us to the end of this topic on noise pollution. Thank you for your attention and participation. I hope now you have better understanding on how noise is measured, why it matters, and how it applies to environmental and occupational health. If you have any question, feel free to ask. Thank you.